My name is Tex. Just Tex, I'm like Madonna. You're all here for web internationalization, I hope. I have a lot of material. Oh, let me get my other clicker. This was a 3-hour tutorial which became a 45-minute session. So I tried to cut it down, and then I also ended up adding some new things because the web keeps changing. So buckle your seatbelts. I'm going to go through a lot of stuff. I'm going to try to go through it quickly but clearly. But I think the most important thing is that we make good use of the time. So if I go too fast or if I skip over something you want more of, please interrupt me. I'd rather the discussion was interactive. Doesn't make sense for me to go through a lot of stuff and you guys just see a blur. Some of it is fairly basic. Towards the end, you get some of the more interesting stuff, but I think this is intended to be good coverage of everything you need to know. Does that make sense? You guys going to talk or just not? All right. Let's see if this works. All right. So I've told you good news and bad news about compression. So here's a sample page I did years ago. Has a little bit of French on it. Has an English translation. It also has this additional line that says, don't forget to put prices in euros. And I said, great, I'm all good. But I happened to travel to Japan, and this is what happened. And I said, well, what's going on here, right? It was pretty clear when I wrote it. And you can see there are several things that are wrong. And it was because, as you might guess, the browser doesn't have information about the encoding. So it was a Japanese browser. It just assumed the Japanese encoding. And it misinterpreted some of the Latin characters as kanji. Not only did it mess things up, but it actually confused the markup, right? So here's some markup that shows through because it's not parsing the text. And as you might guess, that could cause a lot of problems, especially if you're embedding programming languages in your pages. And in some cases, problems might not even be obvious. I mean, it was clear I said euros here, so you knew this was a euro symbol. But in another circumstance, it might have been a symbol that just got changed to something that looks like a bullet or something else. And your user is going through the page saying, oh, this is a good price. I'm going to purchase it, not realizing what the currency was. And you can have all sorts of other misunderstandings, right? So this is significant. There we go. So the problem was the browser didn't know the encodings. There's lots of encodings, and many of them exist. How does the browser know what the web page should be? And you might say, well, why can't it just scan the bytes and figure out what the encoding is? And sometimes you can. There are heuristics that do that. But supposing I send you an email, and I'm here in the US, and I'm using this old code page 8859-1, but you're in Russia, and you're using this Russian code page, and my message is just 1 byte, FF. Well, so what's the character? It could be Y with 2 dots, because that's what it is in this encoding. But my Russian friend is going to see this character, and he's going to go, why would he send that? I'm not sure why I would have sent the Y with 2 dots either, but you get the idea. So just having bytes is not enough. So what's the solution? Well, there are 2 requirements. You need to have standard names for the encodings that you're going to use, so we can go back and forth and say, I'm using this. That's how you interpret the bytes. And then you need a mechanism for labeling text with an encoding. There is a registry of all of the encodings. You can go to this website and see the list of them. But more recently, clicker doesn't always click, the W3C said, we're going to list the encodings we think browsers must support And user agents, browsers, should not support any others. And we want authors to always use UTF-8 as the label, and the ASCII insensitive UTF-8 is the right string. And there are a lot of reasons for limiting it. You could argue, what about my encoding and my legacy data? The case was made that bring everything to UTF-8 where you can. And one reason is because security on the web has become a lot more important. So use UTF-8 everywhere. You may still have to think about encodings, especially if you're bringing data out of legacy apps or legacy databases or for other reasons. But for the web, we should be using UTF-8. Well, so now we have names, and in particular, we have UTF-8 as an official string. And that dash is important, because I've worked with people who were having problems on their websites. They said, we called it UTF-8, but either they didn't have the hyphen, they used an underscore, or they didn't have anything at all. And because other programming languages were using other identifiers for UTF-8, and they got used to using that, and they put the wrong thing in, and the browser simply didn't recognize a string that looked like UTF-8 but wasn't exactly UTF-8. So we have official names. Where do we put these labels? So if you're setting up your server so that it sends out HTTP, you can declare that it's UTF-8, and it gets put into the HTTP response. This is what a response looks like. 200 is a success. It says it's using HTTP 1.1, and it says the content type here is text, HTML, and the char set is UTF-8. So your browser sees that and says, okay, I know how to interpret this page. The default for HTTP for most servers was 8859-1. So you want to make sure to set your servers to declare the right string. You'll see I have links and references throughout. I'm not going to read them all off, but the slides should be available through the conference. Still have a little bit of information. I've cut out a lot of the information about older browsers, but just so you know, HTML version 4, they use this HTTP equivalent statement essentially to say, use the same syntax as was used on HTTP, which is why it's HTTP equivalent. So you could put that in your older version pages, but you should be using HTML5 by now, and this is the proper way to do it. You use the meta char set statement, declare the encoding there. It must be in the first 1K bytes, right? So the browser reads it. Not only should it be in the first 1,000 bytes, it should be the first thing in your file right after the head statement, because the browser doesn't know the encoding until it reads that. And if you have statements ahead of it, maybe you're declaring keywords or putting other information into your head, well, if that's in other languages, if it's not ASCII characters, that may not be interpreted correctly. Once the browser gets out of sync, remember how the markup got confused? So you may have problems. Make it as early as possible in the page. Now, if you're not using UTF-8, you can use UTF-16, and then you use the byte order mark in order to indicate that that's the encoding. If you have style sheets, you also can set the encoding of your style sheet. This at char set statement must be the first line in the file, or you can use a byte order mark to indicate the encoding. Now, you used to see, and you may still find in some of your older pages, where it wasn't done very often, but it was sometimes done, where you could declare the char set on a link statement. And that's been deprecated, and frankly, it didn't make sense to do that, because if you're declaring the encoding of some other page somewhere else, if that author or owner changes that encoding, who's going to update all of the links that point to it to know about the new encoding? So it would just be wrong. So anyway, that's been deprecated. It wasn't well supported, but you may find some instances where people were doing things like that. All right, I've told you a few different ways to declare an encoding. What if I see more than one? Who wins? Who rules? In HTML5, the specification says, well, first of all, a user can change the encoding in their browser. They're viewing the page and they say, well, I want to use a different encoding. Maybe they don't think the data looks right for some reason. If your server has set HTTP to declare the char set, that's going to outweigh everything else. So you really want to be careful, make sure your server is set with the right encoding. It should be set to UTF-8 or not set, right? Byte order mark is also a possibility, and if it's not declared with those, then HTML5 says it's either the meta-char set statement or this HTTP equivalent statement. If it has no information, it's going to use some kind of heuristic to try and figure out the encoding, which is how I got into trouble, right? CSS has similar rules. Okay, so we've kind of figured out the encoding, but I speak one language. I would like to tell the server what language I prefer because I want the server to give me data or pages in that language. So how does that happen? All right, before we discuss that, let's talk about how we exchange information between a browser and a server, a user and a server. You type an address into your browser. Your browser converts that to a get URL statement, sends it to the server. The get URL is a mix of here's the domain and here's the path to the page that we want, right? And maybe some other information. So the server selects the page and creates a server response, sends it to the browser. The browser has the job of saying, well, I've got this page, I have to figure out how to render it. Right? If I have a mobile device, it might look one way. If I have a desktop, it might look another way. If whatever the encoding is, my operating system might have a different encoding. You give me a page in UTF-8, but my operating system is using UTF-16. I have to manage the encoding and then figure out how to display. That's the browser's job. So he displays it, and maybe the page has a form in it. So the user then types data and needs to send that back. And so he might post data back to the server so the server can take the data, store it in a database, or do whatever with it, right? That's the primitive view. Now let's take a look back. So, well, the browser or the user agent wants to tell the server a little bit about what information it can take, what languages the user speaks, and maybe also something about the encoding the browser supports, which is a little bit old school. There is a way to do that. That's this accept char set statement, and I've crossed it out because that's not being used anymore, right? It's about 10 years old when people stopped using that. But you may see discussions of it. They both work very similarly. You declare some values along with potentially some quality indicator, and we'll talk about that. Specifically for accept language. In your browser, how many of you have gone into your browser preferences and said, here are the languages that I prefer? You guys are international folks, because most people don't even think to look, and it's whatever browser they downloaded, whatever settings it comes with. If you're in Japan, your browser probably comes and says, I prefer Japanese. If you're in the US, it says English. So this accept language gets set up. But you can go in, you can say, not only do I want English, I want Hindi, I want Japanese, I want Arabic, and you can say, I prefer this one over this one over this one over this one. That gets converted into a statement like this. It says accept language, and it's converted them to language identifiers or language tags. This is English is spoken in the US, or just any English. Croatian is HR. And this Q, this quality factor, that's just a value 0 to 1, and it says, I prefer this much relative to the others. It has no absolute meaning. So a browser can specify that, and it tells the server what to do. The server can use that information and say, well, maybe I have this web page in these languages. Let me try to match up which one is the best one to return to the user in that language. Encoding capabilities are not settable, and it's preferred to return information in UTF-8. So here's what the response would look like. You know, I've told you about this statement, but now you also get this page that I'm sending you is content language English, and then after a blank line, the actual document comes. So now your browser says, oh, I've got English data, there's some things I can interpret about the information on this page to help me to display it or do other things with it. However, let me see. So you can also configure your server to add language information. It's not a good idea. The information is best located within the page because your author and the people working on the documents know the language. Whereas if you set the server, if somebody provides a document in another language, it's going to override what's on the page, right? So now, the browser has the page. As I said, it's going to try and figure out how to render it. And now the user wants to enter data into a form. So the browser takes the user's data and it creates what we call a form data set, which is nothing more than a combination of control names and the values. So I have a control that says he sent me his name. I'm going to call the field name and then associate the value with it. And there are three ways you can send data back to the server. So here's a simple page. I have an action which tells the browser what address to return the form to. It says I'm encoded in this form URL encoding. And so here's the information. I've got a name with an input field. An input field that says its name is the name of the control. I've got radio buttons. The name of each of the buttons is called sex, and one has a value M, one has a value F. And then I've got the button for sending. It's going to be rendered like this. And the form data set is going to have these control name and current value pairs, and you can see it says name text, sex is M. And three ways to submit it. I can do a get with the URI, or I can do a post with the URI. And then there's a third way, which is this multi-part form, and I'll talk about that. But first, this is the same information. This is what it's actually going to look like that it sends. So if my form, if the action was said to go to this URL, and then it appends with a question mark, name equals text, ampersand, sex equals M. You're all familiar with this kind of encoding? Have you? You see it every time you do a search or scan for information from any kind of website. It takes whatever information you've given it, and usually it puts it up on the URL if it's just a query. You guys there? You seen it? All right, so I'm going to blow through it pretty fast then. So these are the name value pairs, as we said. You get the names of the controls separated from values with an equal sign. If you have more than one, you get an ampersand, repeats it. Some characters, like the spaces, are replaced by plus signs. And everything else, especially the non-ASCII characters, the byte value of those characters is converted to %HH encoding. So now, if the server doesn't know the encoding that the browser is sending the data over, it's the same problem I showed you before. If I just get bytes, I don't know how to treat it as a character. And usually what the browsers do is whatever the encoding of the current page is, that's what it interprets the bytes as, and that's what it sends. So if I had a page that was in ISO 8859-1, C Sadia is just 1 byte in that encoding. And that's what it's going to send. On the other hand, if it's UTF-8, C-SADIA is 2 bytes, C3A 7, and it's going to send that. So obviously, if the server doesn't know the encoding or chooses the wrong encoding, then the values look incorrect. And some of you may have seen this from time to time, or stored incorrect data in your database as a result. So it's really important to get that right. Which is why you want the pages to be consistent, and you want to set your encoding to UTF-8 and make sure that the data comes back in an encoding you know. Now, I've showed you with the GET request, the POST format looks the same, and the third form is this multi-part form. And I won't describe that in detail, but essentially, instead of being on the URL, the information is not visible, but sent along to the server. And it has several advantages over using the GET and POST with the URI format. For one, it's not visible to the user, so they can't inspect it if you're sending information you want to keep private. It's also sent binary, so it's a little bit more efficient. But also, the length is not limited. So now, how many of you know what the maximum length is of a URL, of a web address? Any guesses? He says 1024. I heard 1,000. 65,000. Any lower bids? Any higher bids? So the standard says, if I remember right, 2048. However, not all browsers support that. And in particular, years ago, mobile devices often were very limited. Some of them were limited to like 256 bytes, right? So you design your application, you have all this data going into a form, and it might get truncated. I think mobile devices are better now. I'm not sure they all meet that standard. But if you use multi-part form for sending information, then you don't have to worry about that being truncated. Okay. Now, I mentioned sometimes a user might choose to override the encoding that you send to them. They might change the encoding. So this slide just has a couple of things you can do. If you use hidden fields, you can put special values in there. If they change the encoding of the page, those values can change. If you're clever, you can put in values not only that will be changed, so you notice something happened, but also you can detect what encoding they changed to and maybe reinterpret the data. At the very least, you may want to check that the user hasn't done something to change the encoding of the page. If you're working with with Microsoft browsers, they have this nice little feature where if the name of the hidden field is underscore char said underscore, then it returns the actual encoding, the Windows or the Microsoft name for the encoding. So that's nice, but it only works for their browsers. Okay, good so far? So you'd like to input data, and not just text, but data of all sorts of types. HTML now has several different data types you can use, actually quite a few actually, for entering information like numbers and dates and times. And so I won't go through this list, but you can look for it, and you can also check other information sources. But to give you an idea, if I say the input type is date and the input type is time, then what it's going to submit is a URL. It says here's where it starts. So the name for this field was day and time. So day equals, and it's going to be always year, month, day. And the time also with the colon, %HH encoded. And this way, no matter where people are sending you information from, it always comes to you in the same format. So on the server side, you can parse it. Now, how the data gets input, that is determined by the browser and the operating system that you're on. So on the one hand, that's good because it's consistent. On the other hand, it doesn't respect the language setting that you put in your page. It's whatever language the operating system was set at, okay? Or maybe how the browser was set? No, it's the operating system. So for example, the Windows regional settings and not the HTML lang will set it. And also if you're setting on your page, direction is right to left, but the system isn't set to right to left, it might be a little bit confusing. But other than that, you get some nice date and time pickers. So I mentioned language identifiers, and I think most of you have seen this. I will describe it somewhat. So this is comes from a standard BCP 47. So the language identifier is composed of several fields. There's a language tag. Then there can be optionally an extended language tag, a script tag, and a region tag, and then some other special use tags. So language tags all come from these standards ISO 639 and ISO 639-2. They're 2 or 3 letter codes. I'm guessing everyone in this room is familiar more or less with those. Sometimes you want to have a script tag because some languages can be written in more than one writing system. So Azerbaijani is Arabic, Cyrillic, and Latin characters, and that makes a difference because not everyone who speaks that language can read all 3 of those scripts. And then you have 2-letter region codes and these 3-digit codes from the UN standard, and that the region codes, the 3166 codes tend to be mostly country codes. The UN codes tend to be regions of all sorts of granularity. You can say Latin America is 419. So if you want to say this is Spanish for Latin America, kind of a universal Spanish, you would say ES for the Spanish language, 419 to say this is good at anywhere in Latin America. And you can get more information about the possible tags from this language subtag registry at IANA. And here are some examples. Some of the more useful, well, they're all useful, but some of the ones you should know are to be able to specify Chinese, ZH, in traditional writing system, which is Han T. On the other hand, if you want to say simplified Chinese, you can specify Han S. And then you can also make it more specific to CN for country or HK for Hong Kong. And you can also distinguish Mandarin versus Cantonese and so forth. You see the CMN and YUE. And so you can look at these and get some ideas. And it's a good idea to declare the language. It really helps your browsers and search engines, etc., figure out how to properly render your document. Now, in your document, especially if it's a multilingual document, you may also want to set different language identifiers on particular sections of your document, particular items. And in CSS, you have 2 kinds of, I'll call them filters. One is a language pseudo-class. So I can say if my language is Chinese, using the lang pseudo-class, then maybe I change the font or do something else. And the nice thing about this pseudo-class is the language is presumed to be inherited in lower elements in your DOM. So it will work with that. Now, attribute selector can be a little bit more specific. If you use an equal sign, it matches exactly the attributes you set. If you use the pipe equals, then it's also it uses it as the beginning of the tag. So if I do lang pipe equals FR. It's any tag that begins with FR will work. And so I'll give you an example here. Essentially, I've created different rows with English, text in generic English, meaning just EN, ENUS for American English, French, just FR, and then FRCA for Quebec French, and then an ENGB. And you see up here, I've set bold and green for ENUS using the pseudo class, and use the attributes. Anything beginning with FR is going to be red and italic, and here's how it looks. And you can see this has been selected, right? How many hands was that added? 20. Oh, good. Thank you. So, great. How do I know what the user prefers? What are people doing to figure that out? Come in, Rangoon. You ask them specifically. That's one way. So you can give the user a control and give them a button to select. They can make the select if they have a user profile. You can also ask them that information when they design their profile and then look it up every time they're using your system. Sometimes people put the information in a domain name. So like es.zencraft might be Spanish. You have to figure out if that means Spanish, if you're using it for Spanish language, or maybe if I did zencraft.mx, well, that says it's Mexico. That doesn't mean the user wants Spanish, right? So you want to be careful. And then you can also append it as a part of the URL. Also, for certain products, you might apply default settings. There are some heuristics for kind of guessing the user's language. So we talked about the browser language setting. If the user is on a mobile phone, if they're on a device, maybe they have that set and maybe it's a good selection. If it's on a desktop, it's a lot less reliable. Several of you said you don't set your preferences in the browser. Also, the user might happen to be connecting, they're logged in from a hotel, an internet cafe, or they have a shared system. They may not be able to control the system settings. There can be a lot of reasons why that information is wrong. And then people use IP geolocation. It's the same issue. You're knowing what country they're in, and in many countries that doesn't tell you the language, right? And it could also be somebody who's just traveled there. So you might have a mix of these and try and prioritize how you get the user's information. The best way is to have them explicitly tell you what they want. Now, so there's the way you tag your documents, and then there's the way the user specifies the language they want, and you want to match those up, and they might not be exactly the same. I might say, give me a document that is Chinese and simplified Chinese, ZH-Han-S, but maybe the documents are just ZHCN, right? So there are rules for, or best practices described in 4647. It's an RFC you can get at, if you just search for it, and it tells you the different possibilities for how you can make that work. The other thing is, you'll often see described, HTML describes a method of truncation, which you're probably mostly familiar with. So if I have FRCA, I might truncate it to FR. But you want to be careful. There's what HTML suggested. There's what different programming languages do. And so they don't all do the same things. And especially if you have a lot of different technology in your stack, you want to make sure that all parts of the stack are working the same way, so it's at least consistent, so you don't get surprised. So this is something that you should be thinking about and inspecting in your architecture. Most of you know there are different ways to represent characters that are hard to type on your system or otherwise to enter, or to make them specific because several characters look the same. Maybe you want to distinguish one kind of dash from another kind of dash, and just having it in the document, you can't tell which one it is. So you call them out with numeric character references. There's hexadecimal and decimal ways of doing it. The syntax for how you do it in HTML is different from style sheets, and you can do a 2-digit or 6-digit in CSS, and they have named references. So most of you, if you're working with HTML, you know that. An important aspect of it is the way the web is designed is it always references the Unicode value. So if you have a character that's above the basic multilingual plane, in other words, its character value is bigger than FFFF, it still uses one value, whatever the Unicode value is, as an up to 6-digit hex number. And there are a lot of good reasons for doing that, but when you go into other systems, they may not do that. So for example, JavaScript might represent it as two 16-bit units. So you want to be careful. This is the right way to do it in HTML and CSS. But then if you're converting over to other programming languages, make sure you know what they do. And I'll offer one other caution. Often people look at this Windows and encoding. They're familiar with the byte values from this encoding, which is ISO 8859-1, Windows 1252. And in during the 90s, Microsoft added characters in this space, which in 8859-1 was control codes. So people think, well, the euro symbol is at hex 80. Well, in Unicode encoded the original 8859-1 in the first 255 bytes of Unicode. So that value represents a control character, as do all of these. So this is why you often see websites that are dealing with smart quotes and some of these other characters of the euro, and they have corruption of one sort or another. It's because they're mapping this to where there are control values, not Unicode values. So make sure you don't make that mistake. And where you might see this a lot is where people are creating escapes and they think they know what the right values are. One other recommendation from the Web Consortium is you can use either the CSS style, this backslash, for an escape character, or the HTML format using ampersand #. When you're specifying inline style statements, you can use either form. But they recommend you use the CSS format. And that's because if you have an inline style recommendation using that, and then you want to move it to an external sheet or move it elsewhere, then it's not going to work if you're using the HTML escape, right? Because the HTML escapes don't work in a CSS document. So you can see here in this table why that recommendation comes about. Okay, quickly, because we've talked about normalization in at least 3 other sessions. Unicode has several ways of representing characters, and also several characters that look very similar. And if you go to search for a number 2, there's a question of, well, do I want just the ASCII 2s when I'm searching for that? Or do I also want to find it if it's used in a subscript or a superscript, or in a circled value, or in some other representation? So you have characters like A with ring above, which is encoded in Unicode in a composed form. It also can be represented by the letter A and a combining ring above, right? And also it's encoded, sometimes other characters get brought into the standard because they're almost the same, but there's a legacy standard that had it with a different meaning. In this case, there were some scientific standards that used this for angstrom, and in order to have conversion capability, they encoded it in Unicode. But these three ways are three ways of representing the same character. They're considered to be canonically equivalent. No difference. They display the same. They should be treated the same wherever you see them. On the other hand, you have characters with formatting, superscripting, ligatures that are like FI, where it's just the same thing. It's typographically brings the characters together, but it's equivalent to F and I. So those are called compatibility equivalents. And Unicode said, well, what should we do? We need a standard representation. We could have all of the characters move to a composed form, if that makes sense, and we can deal with just the canonically equivalent characters. But then some people might want all of the characters in a decomposed form because it's nice for pulling out, let me just see which accents I want to match, or diacritics. On the other hand, maybe I also want to make all the compatibility characters look the same, and either composed or decomposed. So Unicode said, well, we can have all four forms: normalization form C and composed, decomposed, or compatibility composed and decomposed. And they each have their different uses. Domain names, you want characters that look similar to be treated as the same value on a domain name. Otherwise, you get all sorts of spoofing, and that causes problems. On the other hand, so for domain names, they went with NFKC. The web said for HTML, we want normalization form C. Put all the characters into a composed form because it's most efficient, but also we don't want to change superscripts to regular characters, right? Those typographic differences can be important to the meaning of the document. So they said we can only do canonically equivalent composition, and we'll put it in composed form, and so that's the standard here. And they went, they also said, well, we're not just plain text, we also have escapes. And so they went a little bit further. The Web Consortium said, let's define fully normalized text where we take into account escape characters, and let's make sure that the text is not only in normalization form C, but it takes into account escapes. And so here we have Susan, and the C to D is escaped, and that's fine. They're both considered fully normalized because these are fully composed characters, and because there is no B with a Cedilla below, this is also considered normalized B with a combining Cedilla below, even if that character is escaped. But it's not fully normalized if, for example, C with an escaped Cedilla below is there, because it could have been composed as a single character. So the other thing you want to be careful about is when you're passing strings around and dealing with them within your documents, you don't have a string or a buffer that starts with a combining character, because that can lead to all sorts of security issues and other problems. And I'll just caution, normalization is a great idea. It makes a lot of things work the way you want, but also sometimes people are surprised that it doesn't quite always do what they expect. There are some characters that are circled or with strokes through them that you'd say, well, that ought to be just a 2, compatibility 2, but it isn't. If I have a Roman numeral 2, that doesn't become a number 2, it just becomes 2 I's, right? And then if you have numbers in other scripts, those are not considered equivalents, although you can use properties to try and make that work out. Okay. So if you have URIs, this is how you break up a URI. You, of course, have the method for accessing. You have the authority, which is like the domain. And then you have this path, and you can have control information or other information appended to the URL that tells you, once you have a document, what to do with that document. Is that 5 minutes? All right, we're getting there. Briefly, URIs, as we've mentioned, encode bytes. Anything that's not ASCII should be HH encoded. And you should first take the information that's in the path, convert it to UTF-8, and then you can do the byte conversion. It should be NFC, and that will get you a proper URI. And then I will caution, once you have the document, this information that you had before, maybe it's the name of a location in a document where to go. If that was not in UTF-8, you don't want to convert that to UTF-8 because now once you use the information to access the document or maybe an identifier in a database, they will no longer match because they're not in the same byte patterns. So you want to be careful. Domain names, really briefly. You can now have domain names in almost any language, even top-level domains. Those also should be converted to Unicode. They'll go through a process of filtering and massaging to make sure that only the right characters in the right form, whether it's the right case and so forth, are being used because there are some restrictions, sometimes regionally. And then once you have the proper set of characters in Unicode, they go through a special encoding, which is very efficient to keep the strings as short as possible because there is a limit. And so you end up with a string that begins xn-dash, and that's the nature of it. But what you should take away is that it is possible for people to have domain names in other languages, and you should think about supporting those. And in some cases, it makes sense to, you should always show the user the domain name as it's being represented. In some cases, it's also useful to show the ASCIIfied version because that also may give some assurance and be useful in some layers of the architecture. Email addresses also now can be international. There could be the username portion as well as the rest of it. These are the standards that cover that. BiDi. So I think there have been several other sessions on bidirectional support. So I'm just going to briefly outline these. There is a dir attribute which sets the overall base direction of a document, and it's inherited to all the lower level elements. It affects both the alignment, whether or not strings start on the right or the left, and how the text is ordered. There are also some characters, RLM and LRM, which are useful because the way the bidirectional language works is characters have an inherent direction. Some of them are strongly right, some of them are strongly left, but some of them are neutral and change, like some of the punctuation characters. So if you want to influence the direction of a character so it goes in the right place, then you would use these. And now in HTML5, there is a really terrific element, which is BDI, which lets you set the direction, and it isolates it from the container. One of the things about the bidirectional support is that the overall flow affects the flow of other strings that are embedded in it. And if you're pulling data out of a database or from other locations to display, you may not want you may want the flow not to be influenced by its container, right? So it's handy for that. What's that?
All inline elements with dir are isolated in HTML5.
Okay.
Span B is that.
Oh, okay. So you don't need to isolate with BDI, you can just do a span?
That's right.
All right, I guess I missed that. All right, I'll let you look at this separately. And also, relatively new for CSS is these logical property names. This is for when you're doing vertical or bidirectional writing, and when the writing mode is different, or the direction or the text orientation, you don't want to be saying, I want to set my text to start on the left. I'm getting warnings, frantic signals from Addison. But we have a break coming up, so give me a couple more minutes. Or go take your break. I'm fine with it. But I think we're just at the end. So you don't want to say left and right, and even top and bottom and are not clear when you start changing the direction of your text. So there are a number of properties now that have values like instead of left and right, you can say start and end, or instead of top or width, you can use inline size or block size. This diagram kind of gives you an idea of how to use it and how it would work. And you get some references. There's some other stuff. That's it. I'll take questions. I'll hang around for a little bit. Please remember to fill out your evaluations. And I hope this wasn't too compressed, and I hope you learned something from it. So, yeah. Thanks, everyone. So